LFOs and envelopes are two control modules. They won't make any sound by themselves, but they are used to control other parameters, and they can do amazing things. They are very common and powerful modules to the point that you can find them on almost every synthesizers, and you can even find several of each on a lot of them. Basically, LFOs and envelopes move parameters over time, which brings movement to your sound. And movement in the sound is a key aspect of interesting sound design. Well, apart if you really want to go for a static aesthetic, but you get what I mean. So what do they do? We saw the LFO briefly in a previous video. LFO means low frequency oscillator. So it is basically an oscillator, but as the name states, it oscillates very slowly, most of the time below the hearable spectrum. LFOs come with different parameters. The shape of the oscillation, that can be a sine, a triangle, a square, a sawtooth, etc. Serum's LFO even allow you to make your own shapes. The rate, which defines the speed of the oscillation. You can then link that LFO to any parameter, and the LFO will move this parameter along with its oscillation. So you can achieve different effects with that. You can link that to the amplitude or the volume of an oscillator to create a tremolo effect. Then if you crank up the rate of the LFO, it begins to add harmonics to the sound, and you enter in the domain of AM synthesis. You could also link the LFO to the pitch of your oscillators to create a vibrato effect. If you crank up the rate and the amplitude of the LFO, it also adds other harmonics to the sound, and you enter the domain of FM synthesis. LFOs are also commonly used on a filter's cutoff. With a low-pass filter, for example, which will cut the higher frequencies, you could create some wobble effect used a lot in dubstep. And you can then automate the rate of the LFO to create rhythms. On Ableton's operator, you can link the LFO to the amp or the pitch of any oscillator by clicking on the LFO section and then selecting what you want to affect it to in this middle area. And in Serum, you can find the LFO here. You can then drag and drop the LFO on any parameter you'd like it to affect. To create some movement in the sound, an LFO is also often used on the waveform or on the pulse width of an oscillator, so the source sound of the synth will change a little over time. These are just a few examples to scratch the surface of what an LFO can do. But remember, you could use an LFO on pretty much any parameter of any module we've seen and will see in the future. You can use an LFO synced to the tempo to use it rhythmically, or use it with a slow rate to add just a little bit of motion. Or when you crank up the rate of the LFO, you might discover new types of distortions. Just like when we modulate the pitch of an oscillator very fast to have FM, you could find interesting things if you modulate very fast a parameter of another effect. Here is, for example, what happens when we modulate a phaser very fast. Try to use an LFO on many parameters, changing the wave shape, the rate, and the amount to make different effects. Some LFOs also allow you to use them in one-shot mode. In this mode, the LFO shape will be read only once, which turns the LFO into an envelope essentially. Envelopes are also modules that won't make any sound on their own. Their role is also to affect other parameters. To see exactly what it does, let's use an envelope linked to the volume of an oscillator. That's the most common way to use it. Then it's called the amp envelope. Every synth would have a built-in envelope linked to the amp of the oscillator. An envelope comes with 4 parameters, A, D, S, and R, for attack, decay, sustain, and release. These refer to different stages of what happens when you press a key of your keyboard to play a sound. The attack determines the time the note takes to reach full power from the moment the note is played. So with an attack at the minimum, at 0 millisecond, the note appears directly at its full power, and with a longer attack, the sound fades in. The decay is the time it takes between the attack and the sustain is the volume of the note when the key is held down. If the sustain is all the way up, the decay would have no effect, because it would make a transition from full power to full power. And the release is the time it takes for the note to die off after the key is released. So the longer the release, the longer the fade out. So for example, if you want to make a more percussive sound like a xylophone, you can put the sustain and the attack all the way down so the length of the note would be controlled by the decay. and you can then have a longer release, so in case you play a very short note, it will still resonate a little. And if you want to make a pad sound that would be softer, like a violin, you can have a longer attack with a longer release, and you can have the sustain all the way up, so you don't have to worry about the decay. As you can see, the envelope is pretty powerful to shape the sound as you want, and I think it's one of the most important parts of a sound design. But an envelope can control way more than the amplitude of an oscillator. You can also control the cutoff of a filter, which is also a very common thing to do. It is then called a filter envelope. When you see two envelopes on a hardware synth, most of the time one is for the amp and the other is for the filter. A filter envelope should come with an amount or a depth parameter that allows you to control how much the envelope moves the cutoff frequency. This amount knob could go to positive as well as negative values to move this cutoff frequency upward or downward. You can find this knob here on this module, here in Ableton after you clicked in the filter section, and here in Serum it's the little icon next to the knob you assigned the envelope to. So when a note is triggered, the cutoff starts where it is set on the filter, then it moves up or down during the attack phase by an amount set by the envelope's amount. Then the cutoff will go back down or up during the decay phase to read the sustain value, and when the note stops playing, the cutoff goes back to the original value during the release phase. You can then play with the resonance of the filter to hear more or less where the filter is cutting. For example, we have a sawtooth wave that is filtered by a low-pass filter. And we have a filter envelope. The envelope is set with a very short attack, a little bit of decay, no sustain and a short release. So it would make like a percussive sound. With the amount knob, you can tell the filter envelope to bring the filter's cutoff upward by putting it on a positive value. So there the cutoff will start quite low and will then be brought up by the envelope and then go back down with the decay. And there we created a plucky bass sound that can go well with a kick to make like a trance track. If we set the amount knob to a negative value and turn up the filter cutoff, the filter sweep will then create kind of a wah-wah. And if you want the wah-wah effect to open and close, you can make it the other way around, with a longer attack and a positive amount value for the envelope. And if you want the wah-wah to stay open when you play a note, you can crank up the sustain. Then the release will set the time the wah-wah takes to close after a note has stopped playing. If you have an amp envelope and a filter envelope, make sure the amp envelope let enough sound through if you want to hear the filter envelope. You might not hear the filter's envelope decay if its attack is too short, for example. So make sure you have an actual sound going through so you can filter it. An amp envelope and a filter envelope are super effective together to shape your sound, but you could use envelopes on any other parameters, so don't hesitate to try it on the pulse width or on the wavetable position, for example. So to finish this video, let's try to affect a couple of parameters with envelopes. Let's see what it does on the wavetable position, for example. It can really make the sound come alive.
Yeah.